All right, ladies and gentlemen, we're going into the Krebs cycle now, and this is in a series of videos on cellular respiration. Let's get started on this next video. So what is the Krebs cycle? Well, the Krebs cycle is where pyruvate, which we've produced from glycolysis, is processed in the presence of oxygen, creating electron carrier molecules and then ATP. So our goal here is to go from pyruvate, and we're going to have two of these 3-carbon molecules. We want to go through, extract the energy out of them, the chemical energy, and then use that energy to go through and then power our electron transport chain. So our goal here is to use this cycle to generate energy for the electron transport chain. So if we're looking at where we are here in this process. We've already looked at glycolysis, and we produced 2 ATP and a little bit of carbon dioxide. And now we're in the Krebs cycle, and we're generating 2 ATP worth of energy, as well as the electron carriers we'll go through and talk about. So if we're looking at where this occurs, well, glycolysis occurred in the cytosol, and now we are letting this occur in the mitochondria. So it's going to occur in the mitochondria, and specifically the matrix. So if we zoom into the matrix, we can see the Krebs cycle is going to occur here, and we're going to generate ions that are going to go through and power our electron transport chain and those electron carrying molecules. Now, if we look at where the actual electron transport chain is, well, it's along this inner cristae membrane here. The electron transport chain goes along that very inner membrane in that blue line. So to better understand this, let's go through some mitochondria. So to better understand this, let's go through and look at the mitochondria in a little more detail. So if we're looking at the parts of the mitochondria here, well, we're going to have this outer membrane, and then we also have this inner membrane. And that inner membrane is where the electron transport chain is. Now, we also have this intermembrane space. And this intermembrane space is a high pH, whereas this matrix, and this is where the Krebs cycle occurs, this is where we're going to contain enzymes and proteins. If we zoom in on this matrix again, remember this is where the Krebs cycle occurs. There's enzymes, and we have a low pH in this matrix. Now, there's also going to be a vocabulary word, which is called the cristae. And this is just the inner foldings of the inner membrane. And we call these foldings cristae. And commonly people confuse the matrix with the cristae, and some people use them synonymously, but they really are two different things. Lastly, we have our pores on the outer of the mitochondria. And these pores are what allow our pyruvate to enter into the mitochondria, go into the intermembrane space, and then enter the matrix. So we're going to look at the Krebs cycle here, and we're zooming in on the mitochondria. Now, you don't have to know all of these steps. You do have to know the inputs and the outputs, though, for your exam. So we're going to start with our 3-carbon molecule, pyruvate. Pyruvate is going to go through. We're going to enter our intermembrane space. And it's going to go through and react with some enzymes here. In that process, we're going to go through and go from NAD+ to NADH, and we're going to go through and produce some CO2. We're going to create a molecule called acetyl-CoA. And acetyl-CoA is an enzyme catabolized molecule that is formed from our 3-carbon pyruvate. And in this process, this is going to mix with citric acid, and this is going to get our Krebs cycle started. So we're going to start with acetyl-CoA, and we're going to have citric acid, which is going to be a 6-carbon molecule. And as we go through the Krebs cycle, there's a variety of different molecules that go in between. We're going to produce a little bit of CO2, and we're also going to be going through and charging our NAD+ into NADH, a high energy carrying molecule. And we're also going to go through and continue to break our carbons apart, produce a little more CO2, and then continue to charge another NAD+ to NADH, continue to go through, recharge an ADP. We're going to charge it up to an ATP as we go from a 5-carbon molecule to a 4-carbon molecule. And then as we continue along here, we're going to go through and we're going to convert an FAD into an FADH. So we're going from a 4-carbon molecule, again, still to a 4-carbon molecule, to another 4-carbon molecule where we at last go through and put an NAD+ and recharge it into an NADH. and then the cycle starts all over again. Now, we have to understand the inputs and outputs of this Krebs cycle, but we don't have to know each one of these steps. But we can see we're taking acetyl-CoA, mixing it with citric acid, and then we're creating this cycle that continues to go through and generate a small amount of ATP and a little bit of a small amount of ATP and a large amount of electron carriers. We can see we produced 1, 2, 3, 4 NADH. We've produced 1, 2, 3 CO2, 1 ATP, and then also 1 FADH2. Now, if we look at the Krebs cycle here, we've produced a couple of things. We've produced 1, 2, 3 NADH. Technically, the NADH at the top doesn't count as part of the Krebs cycle. We've produced 1, 2 CO2. We've produced 1 ATP, and we've produced 1 FADH2. So if we're looking at the inputs and the outputs of the Krebs cycle, remember all of these reactions are enzyme catabolized. So we're going to input our pyruvate, and then we'll also go through, we convert that pyruvate into acetyl-CoA that mixes with citric acid, and our outputs are the following. We have, in this case, 4 CO2. We're going to go through and generate 6 NADH. Then we're also going to go through and generate 2 FADH2 and then 2 ATP. So if we look at this, when we look at the Krebs cycle, well, in this diagram, we're only producing 1, 2, 3 NADH, 2 carbon dioxide, 1 ATP, and 1 FADH2. Well, here's the thing that you have to remember. At the end of glycolysis, we have 2 pyruvate that are produced. So we're going through and we're multiplying this by 2 to ensure that our outputs account for all of the CO2, NADH, and FADH2, as well as the ATP are produced. We're multiplying it by 2 because there are 2 pyruvate. So, did you guys learn? Well, did you learn a couple of things? Did you guys learn what the Krebs cycle is? Did you guys learn where it takes place? And then did you guys learn the products of the Krebs cycle? You do not have to know the entire Krebs cycle in each of those steps, but you do have to know what the inputs and what the outputs are of the Krebs cycle. This will be the end of the video. I will see you guys in class tomorrow.